Today I am going to present Lsb Image Steganography project. It's based on advanced C language. I am Mr. Chetan. Now I am going to explain little bit about Lsb Image Steganography. Come, let's move on. Yes, first and the foremost thing we mentioned there, Lsb Image Steganography. First we come for that why it we are choosing steganography. Means what is steganography? Means if you wanna hide some secret credential, or we has to send some message, but it has to be encrypted. Means we are not supposed to other people's are not supposed to get what all the things, what and all the message are hidden in that file. That is steganography. Means like hiding the secret credentials. As mentioned here, detect data forgery, message passing, as I told you, and etc. Message passing, we have to send some message, but other people can't predict that what the message is. So that's why we use image steganography here. Let's move further. We came to know that why steganography. Means it is nothing but to hide some data, and that data should be passed to someone without knowing to the other person, third party person. Like if we have the key, then by using that key we came to know that what is the data present in it, like that. Next, where and all this can be used means steganography. Means in military case, because enemies can't predict that what and all the message we are sending to the other person. So that's why we use in military, as like in intelligence agencies and online elections, internet banking and so on. Means in the internet banking, the credentials are so sensitive. Means that are most important, that we can't to share to anyone. So it is used in internet banking also. Now what and all the methods, means how we are using the, means by physical, print and paints, puzzles and digitals. Means by puzzles, means if we solve the puzzle, means we came to know that what is the data hidden in it, like that. But now here we are using digital, means like images. Yes, I told you, no, we chose digital because though different possible methods are available, we would go for the digital steganography. In digital method, the message is concealed with the lowest bits of images or sound files. Means in the image file there are very lower bits, as in the sound files also. By using those lower bits, we can easily hide our data. The current project expects us to implement LSB, least significant bit, image steganography on BMP file, .bmp file. The .bmp we will go further. I will and as well as that LSB also. Here the current project is on Lsb Image Steganography. We came to know that why what is steganography. Further we will go for why LSB and why .bmp file itself only. Now as I told you, why LSB, because here it is mentioned. Let me take an example. The If we take a value of 0, decimal value of 0, if we change or modify the LSB bit as 1, then the value would be 1 itself only. Modifying LSB doesn't change the magnitude of number much, hence it is also called as least significant. Means even though if we modify something, means it won't be affect the whole thing. That much minute thing we have to consider. So that's why here if we change the LSB, means change the bit to LSB, means then it's a very less value, as shown below also, that if we change the MSB bit, what happens, let me see. If we change our MSB bit, means it's gonna be the value of 128. Means modifying the MSB of the MSB changes the magnitude of the number to double, hence it is the most significant. Means not the double, more than that, means it is a most significant, means we are going to get a very big value, then that may changes make the changes a lot, it may affect our image. That's the problem. So that's why we are using LSB, because changing a small value doesn't affect anymore. Okay, let's go further. Why we choose image here? A file which contains a picture is called picture element is pixels. Fixed number of rows and columns are pixel. These pixels would be grouped along with the different information and forms a format. As I told you, we took as I told you we took a image here. Here it is an example here. In that image we contains of RGB data, means that rows in the pixel there are fixed number of rows and columns that together form a one pixel. So here is a example right in front of you. Okay, here it have some RGB data. First look at that the white color having the RGB data of each of 93%, and that black color have a RGB data of 35 and 16 respectively, and that yellow color RGB data is 90%, 90%, and blue with a 0% to form a pixel. Means it's smallest unit pixel, nothing but the smallest unit of an image, and the with a fixed number of rows and columns. If we change a little bit, means it won't affect any further. So that's why we choose a image here. Let me go further. An image format BMP, as I told you, Lsb Image Steganography. I told you why steganography and why LSB. Now coming for the image, I told you it's a very less it's a better one, better in the digital option, and in that image we are choosing BMP file. BMP is nothing but a Windows bitmap which handles the graphic file within the Microsoft Windows, any OS, means Microsoft Windows operating system. Typically BMP file are uncompressed, therefore it's a very large and a lossless file. Their advantage is the simple structure and wide acceptance in the Windows programs. So that's why we are using that BMP file. It's better option, no? That if we it's a large and that's lossless. The main intention is our thing is that lossless thing, and it is also uncompressed because it's a very large file. So we chose BMP file. Going further, in that BMP we have we separated to 4 parts actually. One is BMP header, BMP info header, RGB data, and end of file. BMP header and info header both are same, are merged together, and in that BMP header we got 54 bytes, means that the header file. We are nothing to worry about that. We have to worry about the one thing is that RGB data. For after the 54 bytes, we are taking that 50 from the 54 byte. We are going to take our data, means our RGB data. At last, it's a end of file. Let me take an example here for the RGB data. Means if we further goes on our project, in that encoding part, we will go for the encoding and decoding further. In that we will get I will give some example here. I mentioned here that RGB data of hash is 0, 0, 1, 0, 1, 0, 1, 0, 3, 0, 3, 0, 3, 0, 5 and 0, 5. Means for 1 byte we need 8 byte to encode 1 byte of data. Means hash is the 1 byte of hash, it is a character, and it is a 1 byte of data. To encode that we need 8 byte of data, in 8 byte of RGB data, like that. Further we will explain that. Now I told you know that if we change that LSB, we will get a very less very less changes. The exa file of the image providing a slide. Let's try to change MSB and red color. If we change our MSB it will convert it to like this. There is a very huge change. If we go for that what if we change MSB, then we will get this is as the output. Means it is a very we can identify that there is a very big change in it. If we change LSB, there won't be much change. It's like as it is only. So that's why we choose what LSB. I think now you are going to get some idea about LSB. Now you are coming for this. We are in encoding part. For the encoding, we are going to use -e .bmp file, .txt file, and it's that much need not to give a output file name. If you won't give, it will take as a default.bmp. If we give any name, means it will take that particular name. For that encoding, we have to use this command line. And for the decoding, we use -d. Means we have to separate it. No, for the encoding part, we have to choose -e. For the decoding part, -d. We have to know that. And for that decoding, we use the .bmp and that one file name which is given in the encoding part. When we come to the encoding part, there's some list of data to be encoded inside the file, like a magic string. As I told you at the initial time, and hash and the star we are using as a magic string here. Means it's nothing but a key to find that it is a secret file, like that. After that magic string, we have to know that secret file size extension. Means that file size extension means it's a integer, it's a number. Means integer of a size of 4 byte. Next, going for the secret file extension means first we are going for the what is the size, that extension size. Now we are taking that what is that extension, means there should be 4 characters, means .txt. No, we will get the 4 character there. And going further, we got secret file size. That is, will in that secret file size we have some secret data. No, that is 25 characters. 25 means it's a number. So it's a number means nothing but again it's a 4 byte integer of the size of integer is 4 byte. At last we are going for secret data, means inside that we are going to put some data with 25 characters. For this going further, if we need 8 byte to encode 1 byte of data. Means as I told you in the RGB data, for that 1 byte of R data, for that hash, it's a 1 byte, 1 character. It has 1 byte of data. For that we need 8 byte of data. As for that value of hash, we have that 1 1 1 3 3 3 and 5 and 5 that is the RGB data. Means there are 8 things is there. So we need 8 byte. We need to encode 1 byte of data. So we need 8 byte of RGB data. So for that, as I told you, for the magic string, it's 2 characters. Then 2 into 8, because 8 is there, no, 8 byte of data. So that's why 16 byte of data for the magic string. Coming for the secret file size extension, that is the int of size 4 into 8, that is 32. And next for the secret file extension, it's of a character, 4 character means 4 into 8, it's again a 32. Next, going for secret file size, that is of int size. Int means it's a 4 byte, 4 into 8, 32 byte. At last we are going for secret date, that is contains 25 25 characters, that is 25 into 8, that is 200. At last, if we have that 16, 32, 32, 32 and 200, if we summation of these things, we get 312. From RGB data we need to encode, means we need the value should be more than this, then we can encode the thing. Look at here, if we take that LSB and if we make changes in the RGB data, then here is the difference, that original file and the encoded .bmp file. If you are getting any kind of what differences are there? I think I am unable to find that more differences in it, because we are going to change that LSB bit, means very minute, means least, as it mentioned, least significant bit. So it's a very minute changes in it. As we go further in the decoding part, nothing but if we encoded means that we have to insert some data that is into image, that is encoding, that other person has to decode it, because that person has to know that what is the data inside present inside it. So that is called decoding. So likewise here there are some comments for the decoding. Okay, now if we go for this picture, then we will get a clear picture what is going on and what and all the things I explained earlier. As I told you that for the encoding part we use that hyphen e beautiful.bmp and that secret.txt and that output file name. That's the thing only explained here, that look at the picture, that it is shown here hyphen e, means it is for encoding going for it's the file. If it is the file .bmp, then it takes further, or else it prints a error message and go further. It is a secret. If we provided a secret file, then it goes further, or else it's a print message, because we need a secret file .txt to that has to encode into that .bmp file, no? So that's why. And further, as I told you that output file name, if we give we didn't give anything, means it will take as a default. If you give means it will take that particular name, or else it will take as a default. Here it is clearly mentioned. Look at here. If we didn't provide any name, means create a file with a default name. It's create a file with default name and start encryption. If we give that provided name, means creating that file with a provided name and starts encryption. Likewise for the decryption also hyphen d goes further, check that it's the file is .bmp not, and check that is the output file name is provided or not. First of all, if it is provided, creating that file with a provided name, or else creating file with a default name, as I told you that default name, and starts decryption and stop the thing. This is the whole picture. Well, let's go further. The summary of this project is that expect us to encode a message in such a way that the quality of the image doesn't change much. As I told you previously, and I showed you image here. There is any differences in this image? No, I can't find any. I think I can't find any that amount a huge difference in it, because we change in the LSB bit only, because the small change doesn't affect that much. Means our motto and the summary of this project is that such a way that quality of image doesn't change much. Okay, so from the previous analysis we can do that encoding of bits from message in the LSB of the RGB data. As I told you that we need 8 byte of data to encode 1 byte of data. If we change in that data, means here is the example I mentioned you here. Here it is. For that value of hash, it is a 1 character, means 1 byte. For that 1 byte of data, you got 8 byte of RGB data. That is 11133355. That we need to change that LSB as to according to our the value of hash 00100011. Like that we have to change. For that first value of 00001 it is there, so but we need 0, we have to change it to 0, and further for 0, and we no need to change that, we need 1, but here also we have 1, but then no need to change. If we have that, means no need to change. If we have another bit, means we have to change that, like that. As told you that previous analysis, we can do that encoding from the bits in the message in LSB of the RGB data. That I told you now, 1111, that that is RGB data. At last, that is that LSB value is there now. We have to change that according to our convenient, like that. That's it. Thank you everyone for listening to my presentation. Thank you everyone.